Hey everybody, this is Larry. This is me doing week 4 of the weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Nice, it's a new problem that I haven't seen yet, so always a nice bonus. Today we have 20, I can't even read, it's so hot. 2743, count substrings without repeating characters. You're given a string S consisting of lowercase English letters. We call a substring special if it contains no characters, which has occurred at least twice. We call it okay. So, wait, in a row or substrings at least twice? Your task is to count the number of special substrings. For example, pop, the substring PO is a special substring. Pop is not. Okay, so it doesn't have to be contiguous. But okay, so I mean, I think this is substring, right? Yeah. I don't know. They describe that as substring, I suppose. It's just very weird, but I don't know. I feel everything's weird these days. But okay, so I mean, I think the idea. This is. I feel like we've done similar problems. But I mean, I think that's fine. Yeah, the key thing to do is sliding window or contribution. I've been calling it contribution lately. I don't know if this is a term that, I don't think this is a mathematical term, just to be clear. It's just something that I've been calling it the last, I don't know, I've been calling it for a while. Because I think this makes more sense than sliding window, or at least it is more general than sliding windows. That's how I think I've been thinking about these type of problems lately, and that's why I've been calling them contribution problems. And why I call it contribution problems is that the way I think about it is that for each, there are n characters. If each character is a boundary or whatever, like I'm trying to generalize it, I'll be more specific with this problem. Then what is the contribution to the final answer, right? And here, for example, the way that we would think about it is that for each character, if this character is the last character in the substring, how many substrings does this contribute to the answer, right? So that's the contribution part. Here n is 10 to the 5th, so of course we have to be careful. But if you have done enough sliding windows, this should not be challenging to you, and you should be doing enough sliding windows that this is not challenging to you. But yeah, okay. So then here, if you read or if you watch the daily problem, it's basically the same idea. Here we have the left and the right, but this is a more basic dynamic program or sliding window. Sorry, slip. But yeah, and here we keep track of a set, right? Maybe. And this is just the number of ways you can write it. That's why I'm like trying to think about if this is like the cleanest way to explain it. So if I'm like paused, that's what it is. But yeah, this is basically the set of characters inside the range, right, or the window, right? And here, yeah, now we update the window, kind of. But before we update, we go, okay, is the current character already in, or maybe another way to think about it, is the new character we're adding unique? Because if not, then it's no longer a special string, right? So then here maybe we go, well, S of right is in, oh, that's why I thought S was, sorry, let's just say seen, right? Maybe seen as in seen in range. So S of right, which is S the string, in seen, then we seen dot remove S of left, and then left increment. So basically the idea here is that we're shrinking it one by one until we are able to add this new character, right? And then seen dot add S of right. And then basically the idea here is that the invariant, and I talk about invariants a lot when it comes to both sliding windows and contributions, because these are the things that you should think about every as part of your loops and thinking about what is the thing that always happens after, or you want to keep true, or keep false or whatever. But yeah, and here is that s sub right does not appear in scene, right? And then now we add it. Now it does, right? So then now, now scene contains all the characters in left, right, inclusive. I think. No, there should be. And left, sub, right range is unique, right? Or contains unique characters, right? And then now here we have to figure out the contribution to the answer, right? So this is just the answer total, not a creative name, but that's fine. So total. So the idea here is the same thing that we talked about when on the daily problem. Hopefully you watched the daily problem as well, because why not? It's free. I don't know. But the idea here is that you try to figure out, okay, let's say we have, this string, right? How do we figure out, and let's say we're at A, and because here, looking back, only BA is in the string. So how do we define the degree of freedom, right? The degree of freedom is basically how many substrings that you can create by uniquely choosing the left pointer or left side of the substring, right? And here, with the A, you can choose just 2, right? Because you can choose A and you can choose BA, right? And that's basically it. Let's play around with a more complicated example, but a complicated example may be just A, B, C, D, right? Pretty straightforward. And let's say we're at D. Then now at D, and maybe you can even start with D just so that it's a little bit more, obvious. But there's 4 degrees of freedom, right? Because you choose length 1, length 2, length 3, length 4, and then you cannot go to the second D. So here, basically, the size of left minus right, or so the other way around, right minus left, or the size of that range is going to be, because each character is unique, and each character means that in some way, but in the way that's given to you in S, will give you a substring that is, what do they call it, nice or good, or I don't know, special, whatever, right? So you can just do something like this, and the two equivalent answers, which is this, or maybe right minus left plus 1, right? And that's basically the idea. You can assert that this is true. It's either that or I'm off by 1 and I'll be embarrassed. But yeah. I think one more thing, and I don't think I said it for the daily problem, because I did it in Python, so I made a mistake here in some sense. Yeah. Wait. No, yeah. But the thing to notice is that you're another language, and maybe there's a little bit of, oh, I'm wrong on this one, but I was wrong on the other one. But in some other languages, you can just make sure to look at the return type and make sure that it fits. Here is actually an int because I actually misread this, or I didn't misread it, I was just wrong. So because the way that you can think about the max answer, sometimes it's going. This usually lends itself to a very n-square solution, or like sorry, not n-square solution, but the answer is on the order of n square, which in this case is going to be 10 to the 10, which overflows int, and it is something that you have to care about in, say, Code Force or something like this, where they don't give you the bounds, right? Here's a little bit of hint that they tell you that it could fit in int, but, and on interviews or on Code Force or something like this, you just get a wrong answer, you don't know why, and that is why, right? So it's something to kind of just think about as well. Though in this case, the reason why we don't need it is because the number of unique characters, and remember, recall that we can also write this as, length of scene. The number of unique characters is only up to 26, so it's going to be 26 times n, roughly speaking, is obviously less than that, a little bit, which fits an int, right? Did I already submit it? Nope. Sometimes I just forget to submit some days, and I have to go back and submit it, which happens, and that's just like silly. But But yeah, what's the complexity here, right? This is going to be linear time because we loop over each character once. We're only going to remove, remember that we're only going to add each character and remove each character from scene once. So this is going to be O of 1 per character, which is O of n in total. This is also O of n. So this is O of linear time. It is not linear space though, because scene is capped by 26, which is the size of the alphabet. So it's going to be O of alpha is the space where alpha is the size of the alphabet. Yeah, that's all I have for this one. I'm melting here. It's too hot, so I don't think I'm going to go over anything more. Let me know in the comments if you have questions, of course. If you have good questions, anyway. But yeah, that's all I have for today. Thanks for watching. Stay good, stay healthy to good mental health. Stay cool out there. I'll see y'all later and take care. Bye-bye.